P is a point on the hyperbola x square upon a square minus y square upon b square is equal to 1. N is the foot of the perpendicular from P on the transverse axis. The tangent to the hyperbola at P meets the transverse axis at T. If O is the center of the hyperbola, then find the value of OT into ON. So let P x1 comma y1 be a point on the hyperbola x square upon a square minus y square upon b square is equal to 1, which is standard hyperbola, whose x-axis is transverse axis and y-axis is the conjugate axis. So let us consider the point P here. Then N is the foot of the perpendicular from P on the transverse axis. So let's draw the perpendicular. Then the tangent to the hyperbola at P meets the transverse axis at P. Let us draw the tangent at P. Which meets the transverse axis at P, and O is the center of the hyperbola. And here the coordinates of N can be taken, since Pn is perpendicular to transverse axis, that is x-axis. So therefore coordinates of N can be taken as coordinates of N are x1 comma 0, since point P is x1 comma y1. So the coordinates of N can be taken x1 comma 0, and coordinates of T, so the equation of a tangent, so it depends on the equation of tangent. Equation of a tangent at P x1 comma y1 to the hyperbola is given by x(x1) upon a square minus y1 upon b square is equal to 1. Now to get the point T on x-axis, put y is equal to 0. So we'll get x(x1) upon a square minus 0 is equal to 1, which implies x(x1) is equal to a square, or we can get x1 is equal to a square. We can get x is equal to a square upon x1. So therefore we can write the coordinates of T can be taken as a square upon x1 comma 0, and therefore now distance between OT and ON, since it is O is the center like origin, so OT into ON, which is equal to the distance from O to T is a square upon x1 into, and distance from O to N is, N coordinates are x1 comma 0, so we can write x1. So we can cancel this both and we can write a square. Therefore OT into ON is nothing but the length is a square. Okay.